Hi, this is Mr. Mitchell with a video on balancing chemical equations. A chemical equation looks like this, and you can see that it is filled with elements from the periodic table. So elements, as you may recall, end up forming compounds like this HCl has both the element H, hydrogen, and Cl, chlorine in it. So it's not just stopping whenever you form a compound. These compounds also interact with other elements and other compounds to have what's called chemical reactions. And whenever they have chemical reactions, they often will form new compounds and make new elements that are kind of taken away from other compounds. So whenever you have one of these, they can be written out in this chemical equation. So you literally have zinc bonding with hydrogen, chlorine, in their hydrochloric acid is what this is called. And it ends up yielding or forming this zinc chloride plus a diatomic molecule of hydrogen. So what you have to have is a conservation of mass. Atoms don't just form out of thin air, and you don't just lose atoms out of thin air. All of the things that are present on the left side of the arrow, you must account for on the right side of the arrow. It's kind of like taking 25 children into a big building and scattering them all over the place. You still have to have 25 total children. They don't just disappear or add to. You start with what's on one side and you have to end with the same thing on the other side. They're just mixed up. So by balancing chemical equations, you're taking equations that are not balanced, and you have to know that rule of conservation of mass, that you have to have the same number of atoms on one side as you do on the other. So here's how you go about it. Now, I have emphasized in a previous video what coefficients and subscripts are. Subscripts are going to be these small numbers that are down below. Yes, it represents 2 hydrogen atoms. This represents 2 chlorine atoms. That is part of the chemical makeup of that and part of the chemical makeup of that. But you also have coefficients which can go in front of these, which means you have 2 of, in this case, zinc, or 2 hydrochloric acid molecules, or whatever. There is a rule that you cannot break when balancing the chemical equations. The rule is do not change the subscripts. No, no, no. You cannot change any of the small numbers that happen to be anywhere on the chemical equation. The only thing you can change is coefficients. Because if you change this ZnCl2 to a ZnCl3, that changes what it is. It is no longer the same thing. You're adding electrons to their valence shell, and you just can't add electrons to their valence shell. You have to add like a 2 here or a 3 here in front of it to have that many molecules, and it stays the same thing. So enough talk about that. Let's go ahead and get some action going here. I'm going to bring my pen here and show you how this is done. You've got the arrow here, and I'm going to draw a line down from the arrow. Now what I want to do is look on both sides and see how many of all the elements are on both sides and see what I need to change. So zinc, there is 1 zinc on this side because you don't see a 2 here, you don't see a 2 here, or any bigger number here. So there is just 1 zinc on this side. How many zincs are on this side? Well, I don't see a 2 next to the zinc, and I don't see a 2 in front of the zinc, so you have 1 on either side. So zinc is balanced as it is. That's not going to be the case with all of them. So we have hydrogen. Looks like we do not have a subscript or coefficient here. So there is 1 on this side. And yes, here's where the imbalance starts. There are 2 hydrogens on this side. So you're going to have to change that. You're going to have to get 2 hydrogens on this side. How can we get 2 hydrogens on this side? Can we just put a little 2 subscript down here? No, 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 we cannot just do that. The only thing we can change is the coefficient. So what we can do is put a 2 here. And we have 2 HCl hydrochloric acid molecules. That's the thing we can do. Now, it's not always going to have a perfect solution when you change one. You may have to change one on the other side, and then on the other side, and then on the other side, and just get them balanced like that. But this is a change that may help here. So now we have 2 hydrogens on this side. 1, 2. And we still have the 2 hydrogens here. So now with chlorine, let's see what we have. Okay, so we have a hydrochloric acid molecule here, which means there are 2 hydrogens and 2 chlorines. So that is correct. We have 2 chlorines right here. And let's see what we have here. Yes, we have 2 chlorines right here. So this is a balanced equation because I have the same number of zinc, the same number of hydrogen, the same number of chlorines throughout on both sides. And that is a balanced equation. The only thing I changed was a coefficient. I did not change a subscript. Now, let me take a hypothetical to you. What happened if there had been, say, a number in front of this? There's not, but what if there would have been? How many hydrogens would there have been on this side? Here's how you do this. You would multiply the coefficient times the subscript. And 3 times 2 means there would have been 6 hydrogens on this side. So that's one of the tricks that'll make it a little bit easier whenever you practice this in class. And yeah, you'll end up having a pretty good bit of practice of this in class. So, hope you learned a little bit about balancing chemical equations.